This is the stoichiometry practice problems 1. First thing we need to do in question 1 is to balance the equation. So we need an 8 in front of the O2, a 5 in front of the CO2, and a 6 in front of the H2O. Second step in our stoichiometry problem is to convert our given amount to moles. So we're going to take 25 and then multiply it by the ratio 1 mole to 32 grams, which is off the periodic table. And then we should get 0.781 moles of oxygen. From here, we can do any of the moles, so I usually go and find the next moles that we have. So the next number of moles, or question for moles, is D. So we take our 7.81 moles of oxygen, and we're going to use our coefficient ratio of oxygen to CO2. And we have 8 moles of oxygen, which will go on bottom, and on top we'll put the 5 moles of CO2. Then we'll do our calculation and we get 0.488 moles of CO2. Next, I'm going to do the molecules of CO2. 0.488 moles of CO2, which I have found in calculation D. 1 mole of CO2 is 6.022 times 10 to the 23rd molecules. And when I do my calculation, I get 2.90 times 10 to the 23rd molecules of carbon dioxide. Next calculation I do is H, and these can be in any order. Once we get to moles, we can kind of go in any order at that point. So sometimes it won't look like I'm doing things with any rhyme or reason, but something struck in my brain that made me do them this way. So in H, I have 7.81 moles of oxygen times Avogadro's number divided by 1 mole is 4.70 times 10 to the 23rd molecules. So I'm going to do E next, which is my mass of C5H12. So first I have to find the moles of C5H12, so I take my 7.81 moles of oxygen that I was given, multiply it by the coefficient ratio of 1 mole of C5H12 to 8 moles of O2, and I get 0.0976 moles of C5H12. And then if I take the moles and convert it to mass, so I'm going to take my number of moles and multiply it by the molar mass of C5H12, which is 72.146. And I'm going to put my answer above it as 7.04 grams of C5H6. Next, I can do my grams of CO2. We calculated the moles in D, so we can use that number over again. 0.448 moles of CO2 times the molar mass of 40.01. And I'm going to get 21.5 grams of CO2. And then to find grams of water, I need to first find the moles of it. So I start with the moles of O2, 0.781 moles, multiplied by the coefficient ratio of 6 moles of H2O to 8 moles of oxygen. Then I'm going to find that that's 0.586 moles. And if I take my 0.586 moles that I just calculated, multiply it by the molar mass of 18.016 moles per gram, or excuse me, grams per mole, that's going to give me a mass of 10.6 grams. Then for the total grams of the product, that's the grams of carbon dioxide plus the grams of water. So 10.6 plus 21.5 is 32.1 grams. Now for the second question, I went ahead and moved it up a little bit so it's easier to see. Start off with the first thing is that we already have a balanced equation, so we don't have to do anything to balance this. So we should calculate our moles of K2CO3 because that was my given amount. So 6 grams times 1 mole over 138.21. That's going to be 0.0434 moles. And we can find the moles in D. 0.0434 moles times our coefficient ratio of 1 to 1. The moles in this equation are very easy. Since the coefficients are all the same, the moles are all going to be equal of each substance. So I should find that there's 0.434 moles. And I really could have gotten by without doing the calculation, but I wanted you to see the calculation in each case. So F would be the next thing that I'm going to do since I'm already working with K2O. And if I take the 0.0434 moles of K2O and multiply it by the molar mass of 90.21 grams per mole, I'm going to get 3.92 grams of K2O. Next, we'll go ahead and do molecules of CO2. So the first thing we need to do is find the moles. So if we take 0.434 moles of K2CO3, multiply it by the mole ratio of 1 mole of CO2 to 1 mole of K2CO3, that's going to be equal to 0.0434 moles. Then to convert to molecules, we're going to take our 0.0434 moles and multiply it by Avogadro's number, 6.022 times 10 to the 23rd, over 1 mole. Notice I am writing my units everywhere. It's important that you keep track of those, so write them down. And so my answer when I do the calculation is 2.61 times 10 to the 22nd molecules. Next, I need to find my grams of CO2. Out beside it where it says moles of reactant, that I just wrote that down wrong, so ignore that it says moles of reactants. So 0.0434 moles of CO2 times its molar mass of 44.01 is 2.13 grams. And then our total moles of our product will be the moles of each of the products, K2O and CO2. So it's 0.0434 moles plus 0.0434 moles, and that's 0.0864 moles. Moles are not conserved, mass is.